Welcome to another episode of Inside York Tech, a podcast featuring students, staff, and alumni of the York County School of Technology.
Thank you for joining us on another episode of Inside York Tech. I'm your host, Nick Staub, and it's been a kind of a wild ride here at York County School of Technology for the last 2 weeks. A lot of events, a lot of accomplishments. I just want to highlight a few of those before we start speaking with our guests. So last week we had a town show. It was awesome to see our students in a different light than the way we normally see them in their technical areas. We also had 22 graduates participate in commencement for our Adult and Continuing Education Center's practical nursing program. And then also, probably the biggest highlight, we had 2 of our Hot Rodders of Tomorrow competitive teams participate in nationals in Indianapolis, and they finished 2nd and 4th in the nation, which is just astounding. Definitely want to highlight that. So if you want to learn more about those accomplishments and events, I'd encourage you to visit our website at ytech.edu and scroll the whole way down. You can follow us on social media. But in the meantime, we've got 2 great guests here with us. We've got Aislinn Abbott, who is a 2020 graduate of York Tech and currently studying at Georgia Tech, doing some pretty amazing things. In fact, she's helping to design, manufacture, test, and implement assistive technology for those with disabilities. And she's using her skills learned here through the Precision Machining Technology program in order to do that. Speaking of precision machining technology, we also have our instructor for that program, Mr. Terry Jamison. First off, welcome to both of you. I'm excited to talk.
Thanks for having us here.
People hear precision machining technology, and I think sometimes they don't know what to make of that. So I'm hoping you can give us a little summary or an overview of what does your program entail.
Sure. What you said is true. A lot of people do not know what precision machining is actually about. So one of the first things I normally do is ask a person, name one thing you use in your life that wasn't touched by a machine. I don't care if that's your vehicle you drive, your cell phone, even the heat in your house. So what ends up being for people for precision metal machining is somebody comes up with a concept or design to whatever to be manufactured. And then it's up to us in the precision machining to make the part or parts that goes into maybe an assembly that's something that somebody can use.
You could ask 5 different people that question, and you'd probably get 5 different answers.
Oh, definitely.
But you've been here with us for a long time, and you've probably practiced that elevator speech.
I have. Yes, I have. I've been here for 21 years. It doesn't matter if I have a congressman coming through or another educator. I ask them the same questions, and most times they just look at me and stare because they really don't know what we actually do.
Well, I think that's a perfect segue to talk to Aislinn, because she is one of Mr. Jamison's proteges, if you will. Like I said earlier, she graduated in 2020, now studying at Georgia Tech. So, Aislinn, if you could tell us a little bit about your major and what you're doing at Georgia Tech.
Yeah, so I'm a mechanical engineering major at Georgia Tech. So I'm focusing on the mechanics of how everything works and designing different infrastructure and everything else. So I'm focusing on biomechanics, and I'm focusing on assistive technology and devices and how you can really help people with engineering.
This is technology that's being implemented right away and assisting people right out of the gate. This isn't just hypothetical or classroom studying. This is stuff that people can use immediately to improve their lives.
Yeah, so last year I was involved with a assistive device makeathon, which is like a hackathon if you've heard of that before. But basically we have teams of students and they have 2 or 3 days to meet with someone in our community that has a disability and needs an assistive technology, and they either aren't getting that device due to financial reasons or they can't, it just doesn't exist yet. So that's something that we are helping them with. So we meet with that person and then we are able to create the device for them. So the person that I was helping with my team was actually a 4th grader with cerebral palsy, and she has a very hard time communicating due to her movement impairments. And what we made for her was a keyboard guard. So the only way she could communicate in the classroom was by typing on the computer on her laptop. However, due to her restricted movement, she couldn't press one key at a time. She had a hard time finding the keys that she wanted and being able to move and press them in a smooth manner. So we were able to create this guard that allowed her to rest her hand on the laptop where the keys would be and only press one key at a time. In addition to that, we created a specific stylus specifically for her, made for her hand, how she moves, her specific grip that she was able to use to press these keys in conjunction with that keyboard guard and really give her an opportunity to communicate in the classroom.
And I would imagine you used a lot of the skills that you at least started to learn here, if not fully learned here, in the manufacturing of those devices, didn't you?
Of course. So we had to go through, first of all, talking with your client, talking with this fourth grader and figuring out what it was that she wanted, the design constraints from her, and then moving on to actually designing the device in the way that would work best for her specific situation before finally manufacturing this device and being able to deliver it for her. So in this manufacturing phase, I was actually the person on the team with the most experience with all of these technical skills necessary. So I was able to use everything I learned here at Tech and really teach everyone on my team, not just using hand tools such as drills and jigsaws, but also using things such as a water jet to cut out the holes for the keyboard guard, or a countersink to chamfer them so that her stylus could easily slide into where the keys would be positioned, and that type of thing.
So, Mr. Jamison, when you hear about a former student who's doing incredible things like that, how does that make you feel?
Aislinn is just amazing. She was an amazing student when she was here. She's an amazing young lady now. She truly is. Basically, what she was just describing to you is something that we teach, and it's called a process plan. So she said that she met with the fourth grader first. Then she found out what was needed for the fourth grader to be successful. And then they had to think of a plan, a process plan. Well, we need to do this first. We need to do this second. We need to do this third. And so when you do that, the sum of it all is to come up with the final end product. And that's what we try to teach here as well, is a process plan. How do you get from point A to point B to finish the project? And she just followed it right to the T. That's what she did.
Did you suspect when Aislinn was here at York Tech that she was poised for this type of success after graduation?
Most definitely. Not only was she a student here, and by the way, she was the top of her graduating class, if I remember correctly. So she was that, but she was also the person who was in class striving to be the best that she could be in class. She wanted to do the projects, hands-on projects. She wanted to be the best at them. Not only that, but also the theory side of it. She wanted to know why was this? Ask the question why. Why do we do this? How does this work? Oh yeah, she was definitely poised for greatness. As a matter of fact, I even told her mother at one time, I literally do think, and I mean this wholeheartedly, that the only limitation that young lady has is what she places on herself.
We're just kind of like barely scratching the surface on things that you've done at Georgia Tech. So I want to get into a little bit more of that. Specifically, you told me about being an executive member of Tom Atlanta, which is one of the clubs available to students at Georgia Tech. Can you dive into what that entails and some of the things that allows you to do?
Of course. So Tom Atlanta is Tikkun Olam Makers, which is actually a global organization that provides assistive technology for people who are not able to get it themselves. So the club at Georgia Tech, we've really expanded this year, and we're helping this semester 5 or 6 different members of the community who we call need knowers, who are people with underserved disabilities, and they need that assistive technology. So we take groups of 5 to 6 students at Georgia Tech, and we pair them with that need knower in the community, and they go through that whole process I described before with the fourth grader with cerebral palsy, but over a semester-long period. So they're able to meet with that person and then design, manufacture, and deliver that product to the person in the community.
And how long have you been involved with Tom Atlanta?
I've been involved with them for 2 years. So my first involvement with Tom Atlanta was when I had been creating that keyboard guard and stand and stylus at the Makeathon. And that's when I realized that this is something that I really want to get involved with. I've always looked at how I can use my technical skills and my engineering skills and manufacturing skills to help people and bring up the community. So that's when I decided to join as an executive member. And as an executive member, we've been able to increase the membership by about 200%. It's been a crazy increase in membership. We've been doing tons of outreach in the community. We've volunteered at schools and women in STEM nights just to talk to people and get them excited about engineering and helping people.
So you're kind of all in at Georgia Tech. I mean, you're not just there to get a degree and then eventually a job. I mean, you're in for the entire experience. Is there anything else that you're involved with that we haven't talked about?
Yeah, so something else I've done is actually my first week at Georgia Tech. It was the midst of COVID, so all of the student maker spaces were shut down. There wasn't really much you could do as far as being hands-on and building things. So me and one of my friends who I had just met decided that we were going to walk around campus and see if there was any place we could get in, if we could just see the machines from the outside. We were excited to get started and get hands-on. So we decided to take this tour around campus. And what we found was the Montgomery Manufacturing Mall, which is inside of our mechanical engineering building. And this is a space where we have hired professional machinists who make all of the parts necessary for our researchers at Georgia Tech. This was the only place open. All the students' places were shut down because it was mid-COVID. So we knocked on the door and we were like, hey, is there any chance we could get a tour? Can we see what's going on in here? And we ended up talking to the shop foreman, and he was a little hesitant at first. He didn't want to let us in. He didn't want to really talk too much about it. He was like, you're really looking for these student spaces. So I got to talking to him about all of the mills that he had in there, the lathes he had in there, all of his CNCs, his wire EDM. And I was like, I actually have certifications on these machines.
Huh.
And I started talking to him about what they were doing and my knowledge. And I was just dropping all these keywords and vocabulary so he knew I knew what I was talking about. And he ended up inviting me inside and giving me a tour of the shop and all the projects they were working on. And he actually ended up offering me a job for that semester, working in the shop, creating parts for researchers. And this is what led me to be involved with another professor at the school who is involved with an advanced manufacturing pilot facility within Georgia Tech, and I was able to work for him as an undergraduate researcher from my freshman year.
And this all initiated before you'd even officially started as a student. Is that what you're saying?
It was all due to my training here at York Tech that I was able to walk in with this prior knowledge that most people don't, even when they choose this post-secondary path to go to college and get involved with mechanical engineering or just engineering in general, they don't usually have this background of how things are made. They don't usually know.
So yeah, she brought up a very key point there. Doing from manufacturing for me years ago, we used to hire engineers. The only problem we had was a lot of these students who we hired to be engineers, they went to college to be an engineer, but they were book smart and shop dumb. They would learn all these equations, they would learn this and that, but to actually apply it to something, they struggled. Where that's what Aislinn has. She has that background. Like when she looks at something and she looks at a problem, she can actually start to think of maybe a design and how do we make that design concept become reality? What do we have to do to machine it? What do we have to do to weld it? What do we have to do to assemble it? So she has that ability behind her, which makes her really valuable to an employer, either manufacturing or engineering, that she can look at something and like, hey, this is how you're going to make it.
Well, you mentioned having that hands-on experience.
Mm-hmm.
And in a previous answer, you mentioned the process that students in your program learn
Right.
in order to solve complex problems. I'm wondering if you can take it a step further and give us some examples of the projects that you assign to students to help them learn the concepts that you're giving them in the classroom.
Sure. So it's like anything else. You're not going to start off with the most complex thing that's out there. So we start them off on the manual side, and that's like vertical mills and lathes and surface grinders and different things. But even before you start learning a machine, there's other things you need to learn. So I can put you on a machine, but if you don't know how to do precision measurement, it doesn't do you any good. If I put you on a machine and you don't know how to read a blueprint or the design, what does it actually look like? It doesn't do you any good. So think of it more like a pyramid. So we need to put the base down first. So that is, what are different types of materials? Is it steel, stainless steel? Is it aluminum? Is it bronze? Is it plastic? Is it wood? All those things get machined differently. So we actually have to teach you the different types of material. We actually have to teach you how to calculate an RPM. We have to teach you how to read blueprints. What does this line mean to you? What does this view mean to you? And then the next thing is teaching you how to do precision measurement. How do I measure the depth of a hole? How do I measure the diameter of a hole? How long is this part? How do I measure this thread? So we have to build, just like I said, a pyramid. We got to start at the basics before we can work to the top. And when we do that, when we work towards the top, we get into computer numerical control machining. So it's called CNC. So we have CNC turning centers. We have CNC milling centers as well. Basically, what you're doing is you're taking a manual milling machine or a manual lathe, or it could be even a surface grinder. And now we actually we put a computer with it. And we have to teach you how to program that CNC machine, that computer numerical control machining. And the reason we have to teach you is that machine is as stupid can get. It's as simple as that. If you put the wrong codes in, it's going to try to do what you wanted it to do, but you're not going to end up with anything good. So we have to teach you how to program the machine, and where it gets its knowledge from is actually from yourself.
I can't imagine that Aislinn, all the freshmen that you entered Georgia Tech with, had all that knowledge that Mr. Jamison's talking about. Did you feel better prepared than some of the people in your classes at first?
100%. I definitely had a leg up in all of the technical aspects of mechanical engineering and my degree in general. Not only was I able to enter these labs and be working and doing research and creating this great network of people that was going to serve me after I graduated and getting jobs or going to grad school, but I also had a leg up in my classes and in the design process. I actually took a class my sophomore year. It was called ME 2110, and this is where you have to build a robot and you compete against all your different classmates. And getting into this class, they started doing training the first 2 weeks. Now, there was the programming side, the electrical side, that I didn't know too much about, so I was into the training for that. And then we got into the shop and they started doing training. And I was with classmates who didn't know how to use a drill, who didn't know how to use a jigsaw, who had never really been hands-on, hadn't been working, didn't know what a CNC was. And that really gave me an advantage.
Well, I think that speaks to just how deep we get into the weeds in a comprehensive technical school like York Tech, because just the fact that, like you said earlier, you could be on campus for no more than a couple days and already have a part-time job offer from someone in the field, that's just astounding.
Mm-hmm.
So I want to ask, actually, the main reason why you first were even on my radar is this $65 million grant that was awarded to Georgia Tech. And I'm going to read this, make sure I get it right. I think it was awarded by the U.S. Department of Commerce's Economic Development Administration. That's a mouthful.
Amen.
So I want to hear from you a little bit about what that grant was helping to accomplish and how you were involved.
Yes, so this grant was developed to combine artificial intelligence with advanced manufacturing. So the part that I was involved with this grant was when Georgia Tech's advanced manufacturing pilot facility. And this was originally developed with a grant from Delta Airlines. And it's a facility with all of these new innovative up-and-coming manufacturing technologies where we can combine both our student researchers, grad school, undergrad, and industry. So industry partners come in with their problems and their challenges when it comes to manufacturing and creating these new complex designs, and we try and figure out how to solve it. So I was a sophomore when I was involved in this lab. So what I was doing was I was working under a grad student, and I was looking at this new simulation software where I could simulate So let's step back for a second. There's some things you need to understand first before I can explain exactly what I was doing. So I was in additive manufacturing, which is where we were doing basically 3D printing of metals. As you can imagine, if you're 3D printing metals, they don't come out super smooth or have a great surface finish. They're very bumpy, they're rigid, rough, and they're not a finished product. So even after you're able to do this additive manufacturing and basically 3D print a metal, you still have to come back in and do the traditional subtractive machining that I was learning here with your mills and everything else. So I was looking at a hybrid machine that could both deposit the metal and then come in with a normal milling head and subtractively smooth up the finished complex shape of the part. When doing this, you have to look at your tool life and how long your tool can last when it's cutting all of these metals all the time, every day. When do you have to replace it? Normally, when people take data on this and they calculate your tool life, they're looking at a smooth or smoother surface finish, or more of a flat piece of metal that you're machining on. So when we're coming in with this metal deposited, basically lump of a shape that has all these rough edges and bumps and lumps everywhere, you have to look at how much the tool will be deflecting from its center point. And so I was using a simulation software to basically simulate cutting this additive manufactured part and seeing how the tool deflection differed from your normal subtractive machining. And then using that to figure out the tool life and tracking tool life and tool wear on your parts in this machine.
I think I followed most of that.
She is
It's
just
hard to
amazing.
explain.
I actually got to see like the machine at like one of maybe the different type, but I was just up at another college because I like to check out to see what's out there, and they had a machine that they were actually doing the 3D metal printing with, and then the same machine, so you didn't have to take the part out. Then you went back in and you machined it to precision, and it was just amazing. So I know it's a little far out there, but it's actually, I totally got what she's talking about. So it's an amazing thing.
Yeah, and I should clarify, your description was spot on.
Okay.
Clearly, they've taken what you already knew at York Tech, which is a lot. I mean, we just talked about how much you learn here, and they're kind of taking you even beyond where I can even fathom and understand.
So Aislinn is actually, I actually changed the way I teach just because of her. When she was here, I really held her back, as in I tried to keep her back with some of the other students to keep her back here. And when she graduated, I was talking to my wife and I said, I got to change the way I teach. And she says, what do you mean? I said, I'm going to release all 4 years of my curriculum to these students. And so I have students that literally come in and maybe they're a 10th grader. And I already had students that were in 10th grade working on my senior level stuff already. Just because of her, literally just because of her, I'm not holding anybody back anymore. If that young person has that desire to learn, they have the skill levels in the whole 9 yards. I'm all about it. You know what I mean? So here's a real quick case in point. So I literally have a student right now who's done all my curriculum the 11th grade year, and he wanted to go into mechatronics. So he's also now a student in mechatronics. I have another young lady who is finishing up all of my things that I have, and she wanted to learn welding. So after this second marking period, she's also going over to welding to learn welding. Now, it may not be as an in-depth as all of our welding students get here, but just because of Aislinn over there, she has totally changed the way I look at things and the way I teach things and stuff like that. So this school here, York County School of Technology, the sky's the limit. It's whatever you want to do, take it as far as you can and go on from there.
Well, you started to hit on one of the questions I wanted to ask you, because I think,
oh man, I'm good.
I think you said you've been here for 21 years.
21 years.
All right. What what keeps you motivated? What keeps the curriculum fresh? What brings you into? Because I've been in your classroom.
Mhm.
I mean, your energy is infectious, and you can tell the students pick up on that. So how do you maintain that through 21 years?
So and I'm actually working on 3 new programs now, like 3 things that I've never taught before. I actually am working on it. The biggest thing, and I literally just told my students this last week, the reason I get up in the morning and the reason I come here is because of just like that young lady sitting over there, but I don't have to be here. I could be somewhere else and doing something else, but I get to be here. I get to hang out with really cool young people who actually want to learn, who are being more successful than I've ever been in my entire career as a machinist, as a supervisor. I actually went into manufacturing engineering myself. They're even more successful, even in the engineering realm, than I've ever been. And that's what makes it exciting, is to see these young people just take it and just go with it. And it's pretty cool that I get to be a teacher here at Tech.
Well, I can feel that because just, being in the same room with you and Aislinn, I get the sense that Aislinn is really the torch has been passed essentially. It was with Mr. Jamison, and now Aislinn is the future of engineering and manufacturing, it feels like.
I agree.
So I want to get back to you, Aislinn. So our application period for new students entering the school for the 2024-25 school year just ended. I say that because we're going to have a new crew coming into precision machining technology here at the start of next school year. You've been through everything there is to offer here at York Tech. What's your advice to those new students who are coming in fresh?
Yeah, so my advice is to really soak in everything you can here. This is such a great school that offers so many different skills you can gain, both technically and academically. And all of these skills that you will be learning at York Tech are applicable to the real world. You're going to be applying everything you learn in your technical program and all of your academics wherever you want to go. It's a stepping stone to go wherever you want. The sky's the limit. So really just take the time and realize everything you're doing here is for yourself and for your future. So do what you can to get all those projects done, to really learn and not just go through the motions.
I got to ask you this question too, because in preparing for this interview, I was looking at some of the photos I'd taken in Mr. Jamison's shop over the last year and a half. And during one of my visits, they were creating replicas of 19th century cannons.
Yes.
Obviously, making those on the machines in your shop out of metal. I don't know which kind. What was your favorite project that you completed here at York Tech?
Oh, wow. It might have been the cannon.
Really?
Yeah.
And those are obviously on a miniature scale.
Oh yeah,
Mhm.
definitely. Yeah. Even to the point of, like, last year, for some reason, we had a lot of people that were do drag racing.
Mhm.
So we were actually making parts for drag cars and stuff last year, different things like that. Years past, we made parts for NASA. So that was sort of nice. We did that as well. But yeah, pretty much anything and everything, it comes down the pike. We seem to get it in our door. Even for right now, the York County Parks Department, we actually have a part up there to machine a mandrel and stuff for them. So that's what's really cool about machining is you have to think of, you just can't say, nope, can't machine that, because you have to think of ways, how can I produce that part? And that's what I really like about manufacturing is you just can't say, I just can't do it. Just like over here for Aislinn, she's coming up with brand new things in robotics or whatever type of stuff. You just can't say, no, I can't do that. You'd have to sit down and you have to be creative. And in engineering and manufacturing as well, you got to be creative and make these new parts that, one day we're going to Mars, but the next step, who knows how far we're going to go out? Could it be the Enterprise, in Star Trek? And could you be a part of that, making it?
Well, I know Aislinn has something to add here, but before I throw it to her, you can't just mention the fact that York Tech used to manufacture parts for NASA without giving me some detail. You got to tell me what that involved.
Yeah. So what I end up being is we actually do competition at Skills USA competitions. And we send people for machining to compete. And sure enough, that particular year, we were #1 in the state of Pennsylvania for machining. And we got to go to nationals and stuff as well. And next thing you know, Houston, where NASA was at that time, they saw us and they're like, "Hey, how would you like to maybe make some parts for us for NASA?" And so I was like, "Sure." So we ended up making these covers. And what the covers were for literally was they put them, for lack of a better word, on a storage suitcase. They put these on and then they get loaded on a rocket and then they get sent to the International Space Station. And then the astronauts up there, they take the things out of these suitcases or storage containers and then they use them, use whatever was inside of them on the International Space Station. But here's the down part. So I said, "Oh, so you guys pack these things back up and send them back?" And they're like, "No, we eject them and we let them burn up in the atmosphere."
Yeah, but even though they may ultimately, become space trash, essentially,
Yeah.
just the fact that something that York Tech produced,
Mhm.
students were involved with it, made it all the way to space, just kind of
Yeah.
like knocks my socks off, to be
Yeah.
honest with you. Aislinn, you had something that you wanted to add to his previous answer.
I did. I was going to say what's great about Mr. J is that he doesn't just force you to stick on just the assignments that are given in class. If you finish early, if you're up and doing all your work, you can pick up extra things to do in your free time. So you can do different assignments, things around school that need to be done. I think I've probably drilled out a few signs that were needed to go up around school. And then another project that I was able to pick up while I was here was with actually a professor at Penn State. He had a wrestling headgear that he wanted to be able to machine a little pocket in that he could put a force sensor in to measure the forces that are put on someone's head and ears while they're wrestling. So that was a really cool project I was able to pick up while I was here.
So the vibe I'm getting from both of you is that you're really not limited to the curriculum. You can kind of go as far as you can take yourself while you're here for 4 years. Is that accurate?
That's true. Yep. Last year I had a student. He is a motocross racer, and he unfortunately, I guess, wrecked his motorcycle, and the back rim, the axle, and everything. So he brought that in, and we did machining on it, and the way he was going. So oh yeah, tractor parts, whatever. Once again, it's all manufacturing. People like it. It's machining. It's what it's all about. If it wouldn't be for us, you wouldn't have half the things in your life. So.
Well, I want to stay on you, Mr. Jamison, because we've heard a little bit about Aislinn's experience going the post-secondary route, going
Right.
to Georgia Tech. But there's a whole nother side of it too. If someone wants to go directly into the workforce, they can. Can you speak to maybe some of the experiences your students have had going directly into the workforce and what type of jobs are out there?
Sure. So currently, right now, we actually have positions for a machinist apprentice, a tool and die apprentice, and basically what an apprenticeship is a company will train you for a certain length of time. So, like for a machinist apprentice, you would graduate here, you would get into an apprenticeship, and then a machinist apprenticeship is 4 years or 8,000 hours additional training at that company. A tool and die maker is for 5 years at 2,000 hours per year. So it's 10,000 hours with it. The really nice thing about that for an apprenticeship, and when you become a journeyman machinist or you become a journeyman tool and die maker, is on average in the state in York County, Pennsylvania, an average apprenticeship costs that company around $250,000 to put you through. Now that's a lot of money, and for an apprentice, you don't pay any of that. The company pays for all that additional training and things as well. So after you're done with your apprenticeship, you get journeyman machinist papers or tool and die papers from the state of Pennsylvania. And you can take that anywhere in the United States and it's recognized as a machinist or as a tool and die maker. So currently right now, yeah, we have enough positions open in the market, in industry, that I can literally have all my 10th graders, my 11th graders, and my seniors out on co-op working at a company as we speak right now. Now, when you talk about apprenticeships, you're just not talking about a $15 an hour job. You're getting into some really nice money that you can definitely make a living on type of thing. Some other cool facts about it is some of my former students, yep, they became machinists, they became tool and die makers. But I actually have some former students that actually went out on co-op, worked at their company for co-op, and then bought the company
Wow.
on co-op. And I have one I had a young gentleman. In fact, it was the young gentleman who was the state champ for us in Pennsylvania for machining. Upon graduation, his brother went here for welding as well, and they started a company up right out of high school, no college education, no nothing. And right now they have roughly 90,000 square feet of manufacturing space, and they have 16 employees. So there is no limits to what you can accomplish here at this school.
That's intense. I like the fact that you can come to York Tech, graduate, and you've got a lot of options. You can go directly into that workforce, get an apprenticeship, go the post-secondary route. It really does seem limitless. I know we've used that word or similar words a couple times here, but it really does feel that way. And speaking of, some of the things that you can get into after graduating from York Tech, Aislinn, I feel like we're talking to like a 20-year seasoned vet in this industry. I mean, just with the experiences you've had, but obviously you're shooting for beyond that. So what are some of those career goals that you have going forward?
Of course. So my goal since I've stepped my foot into York Tech was to be involved with prosthetics and helping people and using my skills in that facet. So currently, I've accepted a full-time job after my graduation this spring, and I'm going to be doing research and design of intraocular devices, which is basically surgical implants in your eye. And that is my first step into the medical device world, and I'm going to be getting my master's at the same time, thanks to the assistance of my company. And post this, I'm going to be able to be working in research and design of prosthetics with haptic feedback and bioprosthetics as well, which is very exciting.
Is she just like amazing or what?
I know. I mean, you took the words right out of my mouth.
Yes, she's just amazingly cool.
I mean, the fact that you've already worked on assistive technology for actual clients, you've been involved in a $65 million grant from the government.
Yeah.
And now that you're going to be working on
so research and design of intraocular devices.
Yes, that's the phrase I was looking for.
That's a big word right there.
Man, that's what throws it over the top, makes you sound extra smart. I love it. Well, that kind of reaches the end of the interview. I just want to thank you both for joining us. I mean, frankly, this has been an eye-opening experience for me, but I think a lot of our listeners are gonna have a much better understanding of precision machining technology and some of the avenues that graduates from York Tech have afterwards. So I just want to thank you both for joining us.
Thank you for having me.
Thank you for listening to this episode of Inside York Tech. Catch all future episodes by visiting ycst.info/podcast.